One basic design feature that substations have is a grounding grid. A grounding grid is a system of bare cables that is buried beneath the substation. All the equipment and structures in the substation are grounded to the grid. If there is current flow to ground anywhere in the substation, it is dissipated to the earth through the grounding grid. Of course, you can't see the grounding grid because it's buried. But if you look at each of the structures and equipment in a substation, you'll find bare cable connected to them that runs down into the ground. Each cable connects to the grounding grid. Many substations also have bare wires that are strung above it. These wires are commonly called static wires. Like the structures and equipment in the substation, the static wires are connected to the grounding grid. The static wires act as a shield above the substation. They provide a path for static charges or lightning strikes to disperse to the earth through the grounding grid. Many substations also use lightning rods to bleed off static charges and provide another path to ground for lightning. Lightning rods and static wires are two common devices used to protect substation equipment. A surge arrestor is another protective device. It protects substation equipment from excessive voltage caused by lightning strikes. It may also protect substation equipment from excessive voltage that is sometimes caused by opening and closing circuits. There are a large variety of surge arrestors that are used in T&D systems. In substations, they are generally vertical porcelain cylinders. The top of an arrestor is connected to a single-phase line conductor. Like static wires and lightning rods, surge arrestors are connected to the grounding grid. Usually, you'll see surge arrestors installed on or near power transformers. This transformer has large arrestors on its higher voltage conductors and smaller arrestors on its lower voltage conductors. Another place you can often find surge arrestors is where power lines enter and leave the substation. Another protective device, called a current limiting reactor, protects system equipment by resisting the flow of fault current. Fault current is basically high current flow caused by a short circuit. As a general rule, a current limiting reactor is an exposed coil of wire mounted on insulators. An energized current limiting reactor is very hazardous. That's why they're usually housed inside a substation control house in a protective enclosure.